Hi, welcome to TrainSignal. Welcome to the continuation of the Windows Server 2012 Advanced Services course. We're focusing on certificate recovery in this lesson. We've talked in other lessons about deploying certificates and making them available, the various things that we would use them for. Here we're going to turn our attention to the important job of keeping them safe. Certificates can be used to secure some very important aspects of our IT operations. And as such, it's really important that we be able to recover those keys in the event of some sort of damage. There are a number of things that can damage one of these private keys. Again, that's the sensitive, internal, privately kept part of a public-private key pair. We certainly run the risk of a corruption of some sort on the hard drive of a user who's using a key. Hard drives do go bad from time to time. Cosmic rays come streaking through the universe and smack into a hard drive and flip a 1 to a 0. It happens. It's a great excuse to use if your server is down. Hey, why is the server down today? Cosmic rays. Cosmic rays? Yeah, high energy particles that come streaming through the universe. Nothing we can do. Sometimes it hits a wire, flips a 1 to a 0. Nothing we can do about it. Really? Yeah, trust me. Anyway, disk corruption, computer theft. What if somebody's computer is stolen and taking the private key with it? Now what do we do? What if a user deletes their user profile through some misadventure of some sort? You may be aware that the user's private key for any certificates that the user obtains is stored in the user's profile. users/username/appdata/roaming/crypto/RSA/ and then there's a folder for your security ID. And inside of that directory sits your private key. So if your profile gets deleted somehow or other, there goes your private key again. For all those reasons and others, it's a very sensible thing to implement some sort of a key archival strategy. Now, we could ask the user to try to archive their certificate and then put that certificate somewhere safe on a USB stick, in a file cabinet, in a locked drawer, or something. But of course, there's lots of ways that a user might inadvertently mismanage that. So how do we make sure that our keys get archived in a way that guarantees that in the event of some mishap with the key on the user's client machine, that we're still able to unpack that certificate from somewhere and recover the private key? Microsoft's main solution for that particular challenge is something called a key recovery agent. I can delegate to somebody inside of my organization the ability to reach inside of our certificate authority server and unpack the key information that lies inside of it and repackage that as a certificate import file that I can hand to the user who's lost their original private key, and I can import that information back into the user's computer. Domain administrators fill this role by default, but a very useful technique is to be able to separate that administration role a little bit and delegate some other user the ability to perform this task. That delegation requires the assistance of something called a key recovery agent template. Now, we've talked about templates in other lessons. If you haven't attended our other lesson on configuring and deploying certificate authority templates, you'll definitely want to take a moment to review that lesson. Having configured that template, we will issue that template to make it available for a user. We'll configure its permissions to allow the appropriate KRA individuals to enroll for that certificate. Once they've enrolled for the certificate, they are a KRA. I'll tell my CA who my key recovery agent users are. I'll tell the CA who to expect will be able to perform this key recovery operation. And, very importantly, I need to configure any other templates that are going to be using key archival to tell them that when somebody enrolls for a new certificate, that I want to cache a copy of the private key for that certificate in the certificate server. It's noteworthy that by default, a CA does not store the private key. It stores the digital certificate, which is the public key, and the binding of what subject name goes with that public key. Private keys by default are not stored in a Microsoft CA, unless you specifically configure it to do so. So if a user encounters a situation where they've lost a key and can't get back into secured, encrypted maybe information, that user is going to go call our key recovery agent. The key recovery agent is going to go find the certificate that applies to this user situation and figure out what certificate serial number is on that cert. Having identified that number, that can be used to unpack a PKCS number 7 file. This contains the information about the certificate and the private key in one combined file. The recovery agent is then going to take that file and extract from it the private key, putting that into a PKCS number 12 file, a PFX file if you're curious to know, that's the extension. That's a file that my user can then re-import on their client machine and get back to work. Whew, sounds like a lot of work. It's actually not all that bad. So let me jump over to my demo environment and let's put this together and see how it works. So here on my Windows 8 client computer, Dawn Clouser is about to start her day of work, so she goes and logs in. She decides that she needs to do some important work related to secure information. She's going to be storing a file containing users' social security numbers. She wants to make sure that the data is kept free from danger if, heaven forbid, the computer were stolen and the hard drive was extracted and the bad guy tried to hack at it. We want to know that the content of that file is kept safe. So encryption is the solution. So Dawn contacts somebody in IT who says, you know what we'll do? Let's get you an EFS certificate and you can use that to encrypt the data. Good idea, says Dawn. So she is directed to launch a tool called CertificateManager.msc. Cert Manager is our mainline tool for administering the local copy of certificates on a given computer. Dawn checks her personal certificate container and finds she doesn't have any certificates. So she wants one. She's going to request an EFS certificate. You might recall that in a different lesson we made available a certificate template called the GlobalMantics EFS certificate. That is part of the Active Directory enrollment policy. And there's the cert that she's going to enroll for. And we run into a problem here. It's complaining at me that it cannot archive my private key. Now what's it referring to? Let's jump over to the server side and see what's happening at the CA that's driving this behavior. So here I am at the CA. I'm logged in as administrator. The certificate that we were trying to issue, the GlobalMantics EFS certificate template, is configured in such a way that's going to require storage of the private key. Let me go show you where that's located. I'm looking at the properties of my certificate template. If I go look at the Issuance Requirements tab, then I'll be looking in the wrong place. If I look at the Request Handling tab, we can see that Archive Subjects Encryption Private Key is selected. So the template is asking the CA, would you please archive a key for me whenever somebody enrolls for a certificate of this type? But at the moment the CA is saying no. Well, why is that? Selecting this option here inside of the template is just one piece of the puzzle. The other piece of the puzzle is in the properties of the CA itself. So let me go back to my certificate authority screen. And I'm going to right-click my CA, pull up its properties, and I have a tab labeled Recovery Agents. And it says, do the following when a certificate request includes key archival, of the sort that my EFS certificate is currently making. What's our response? At the moment, don't archive the key. So that's why I got the error message. The user enrolled for this certificate. This certificate says, sure, anytime that we issue one of these certificates, we're definitely going to archive the private key so it's kept safe. And the CA says, I'm not archiving any keys. So what are we going to do about it? Well, we're going to choose the option to archive the key. And it now wants me to specify the certificate for a user who has the key recovery agent ability assigned to them. Well, that's conveyed again by a certificate. So let's go assign a user the ability to be a key recovery agent. I'm going to cancel back out of this box. I'm going to go back to my certificate templates area. Turns out the ability to be a key recovery agent is driven by a certificate called Key Recovery Agent. I'm going to check the properties of the Key Recovery Agent template. And I'm going to configure permissions on it to grant to a particular user the ability to enroll for this certificate. You'll note that in general, it's not every user that gets to enroll for these certificates. Domain admins do, enterprise admins do. Authenticated users, that's everybody else, generally don't. And I'm going to add a user from my Active Directory domain. Her name is Susan. Susan's going to be one of the main CA administrators. She's going to be a CA manager. I'm going to add her to the list of people who have been given the permission to enroll for a Key Recovery Agent certificate. So Susan's got permission to enroll for a Key Recovery Agent certificate. I'm going to OK that window. I'm going to close up certificate templates, but before I move forward, I'm going to try to avoid making one of the most common mistakes in CA management, which is to configure a template but fail to publish it. Let me publish the certificate called Key Recovery Agent. That now appears here in my list, which means that Susan is able to now enroll for it. So let me do that right here on the CA. She's going to be a CA manager. So I'm going to log out as administrator. I'm going to log in as Susan. Susan wants to be able to get a user certificate, so she needs to launch the Certificate Manager utility, certmanager.msc. She's going to attempt to add a new certificate to her personal certificate store. She's going to go request a certificate for which the certificate type is Key Recovery Agent. She's going to enroll for that cert. That worked. If I go look at her list of certificates, I can see that Susan Bryant has a certificate from Dallas Server 2 for the purposes of being a Key Recovery Agent. Because that's there, here on this local server, that means that the CA can now be configured to reference Susan as a Key Recovery Agent. So what I'm going to do now is to launch back into the Certification Authority GUI, but there's a potential problem here. I can go launch the Certification Authority graphical interface, problem of which is I'm not currently somebody who can manage the CA. I'm Susan Bryant, who at the moment is a Key Recovery Agent, but has no particular privileges on the CA itself. So let me relaunch that as administrator. Right-click there, run as administrator here, and there's the CA. Now, Susan's going to be a manager of this CA, so let me go ahead and change the permissions on the CA to make sure that she can do everything she needs to do. Let's go ahead and add Susan to our list. Susan needs the privilege to read the information in the CA, of course. She's also going to be unpacking certificates, extracting private keys into other files. That is a Manage Certificates permission. Depending upon her job role, I may go ahead and assign her the Manage CA permission, which does fully enable her ability to even make changes to permissions about the CA here. But for the time being, this is adequate for our purposes. Having committed that change, let me jump over to my Recovery Agents tab, where again our goal is to archive private keys if a user issues a request via a template that specifies that it wants to archive the private key. Not every template has to do that. I can pick and choose. I'm going to pick which Recovery Agent certificate to add to this list, and I've got one. Susan Bryant has got one right here. So we'll select that one, click OK. Susan's in the list. I'm going to OK that change. That does trigger a reboot of ADCS. So all that work just to be able to allow Dawn on the Windows 8 client to be able to request an EFS certificate. Yes, that's true. Certainly we could have done it in a more simple fashion. In this case, we're taking some extra steps deliberately to make sure that we can recover that key later if we want to. So let me jump back over to the client machine. Here on the client, you'll recall that our request was denied because we couldn't archive the private key because the CA was not configured to allow it. So let's take another run at that. Now that we've fixed that problem, let's go request a new certificate using the AD enrollment policy, using the EFS certificate template. And that time it worked just fine. If I go look at the list of certificates that Dawn has, Dawn Klauser has a certificate issued by the GlobalMantic CA for the purposes of using EFS. As a point of clarification, let me go ahead and double-click, or alternatively right-click and click Open on the certificate and look at the certificate data. One useful identifying feature of a certificate to help you tell one from the other is a feature referred to as its thumbprint. If I scroll way down here to the bottom of the list, a thumbprint algorithm has been applied to the overall certificate, taking all the information about that certificate and rendering it as this nice simple string of numbers. Okay, I guess simple it's not, but nonetheless it's a recognizable pattern that is going to be unique to this particular certificate. Any other certificates issued by this same CA or any other CA is going to have a different thumbprint according to the rules of hashing algorithms. I like to look at the last couple of pairs of characters as a mental bookmark to remember which certificate is which. So this certificate uses a thumbprint that ends in 9BE6. 9BE6. So we're going to look and see if that piece of information shows up again later in our work. I'm going to OK that window, and Dawn is now ready to do some EFS encryption. So she jumps over to Windows Explorer, and in her Documents folder has an important file of information, employee data, and one important piece of that is the CEO's Social Security number, whatever it might be. That is personally identifiable information. We want to be able to make sure that it is kept carefully guarded, seeing how it's the CEO's Social Security number. He or she would probably be quite upset to learn that that information leaked out to the bad guys. So after I save the file, we're going to take the step of encrypting it using EFS encryption. So we're going to right-click that file, pull up its properties, and here on the General tab, go to the Advanced button, turn on the option to Encrypt Contents to Secure Data, and click OK. Now I could just click OK here and be done, but I'm actually going to click Apply to apply my change. This is, do I want to encrypt that file, just the file, or the file in its folder? I'm going to do just the file at the moment. And I'm going to jump back into the Advanced dialog box. And I note that off to the right of the place where I had checked the option to encrypt the file, I've got a Details button that wasn't there a moment ago. Clicking it, I can see that the list of users who can access this file includes Dawn. Well, it kind of makes sense, it's her file. The reason she can access it is because it's secured using a digital certificate whose digital thumbprint ends in 9BE6. That little bookmark, you may recall, is the one that I identified back in the certificate management tool. So far all looks good. Dawn has encrypted her file. She wants to go see what's inside of it. She double clicks it. Behind the scenes, EFS takes the private key out of her certificate, applies it to the file, unencrypts the content. Everything's happy. But unfortunately, it's not Dawn's day, because in the middle of the night, something goes wrong with the computer. It gets hit by a bolt of lightning, and just by a bit of bad luck, the lightning strike happens to come right through the piece of the hard drive that contains Dawn's EFS key. I'm going to delete the key to be able to reproduce that environment. That we'll have to do for our attempt to simulate the lightning here. So, Dawn has no EFS certificate. Now, one interesting quirk of the way EFS works is seeing how we've used that key to be able to get into that file during this login session. Dawn can still get into the file at the moment. But just to be able to make sure that you know that I don't have any magical secrets up my sleeve here, let me log off Dawn. Log off. That's so early 2000s. We sign out now. We don't log off. Let me go log back in as Dawn. Or sign in, I guess, is the hip new way to say that. When Dawn signs in and goes back to Windows Explorer, goes back to her Documents directory, goes into her secured file, she finds that she can't. She says, uh-oh. That's not right. There's important sensitive data in there that I need to be able to get at and modify. That's my file. How come I can't get into it? Luckily, she knows somebody who can help. Susan Bryant, the CA manager. So she calls Susan and says, hey, Susan, you're smart with this whole certificate thing. I can't get into a file that I encrypted with EFS. It looks like something happened to my certificate or something. So Susan says, no problem. I can handle that. Let me go find the certificate in the CA and see what I can do from my end. And Dawn, here on the Windows 8 client, says, oh, by the way, if it helps to know, the thumbprint of the certificate that I used to encrypt that file ends in 9BED. Thanks to Susan. I may have a need for that. So what Susan's going to do is she's going to go jump onto the CA and see what she can do from that end. Over on the CA, Susan's going to get to work. At the moment, she's currently logged in as Susan. We're going to go visit the list of issued certificates. I see the long list of all the people that I've issued certificates to over the operation of this CA. Might be dozens or hundreds by the time we get to the bottom of the list. And way down here at the bottom, we can see that our most recent certificate issuance was to Dawn Clouser. And that was an EFS certificate. One nice way to double check to see that we're talking about the right cert is to double click it, to go visit the Details tab, to scroll down to the thumbprint, and verify that the thumbprint ends in our bookmark, 9BED. That is the same certificate. I like to use that as a double check to make sure that I'm looking at the right certificate, because it's possible that I issued a certificate to the same person for more than one purpose. Knowing which one is the right one requires a little bit of work. In this case, EFS gives me a nice way to know which one we're talking about. So our next goal is to complete the recovery agent process. A recovery agent is going to engage a two-step process here. One is to extract the information about the certificate and its primary key into a file, something called a blob, a binary large object. And then phase 2, to extract the private key information out of that and turn that into a file that the user can import. And the orthodox way to do that, remarkably enough, is from the command prompt. Let me go launch a command prompt window. I am logged on as Susan Bryant. A quick who am I will always confirm that. If you're wondering who you're currently logged in as in an environment where you've got multiple credentials that you can use, I like who am I for that. So Susan is going to issue a command called certutil. Certutil is the command line tool for administering the certificate services environment. Certutil has a whole series of command verbs that we can issue to be able to make things happen. And in this case, our starting point is this one. Certutil -get-key. Get-key retrieves the private key information from a certificate into a recovery blob. Blob short there for binary large object for those that are curious. So let me issue certutil-get-key, and let's imagine that I don't know how to use this properly. I can do a $? to learn how to use the get key syntax. And what we note here is that in order to use that properly, I'm going to say certutil-get key and identify a search token, where that token could be the serial number. It could be the thumbprint. But one of a number of different identifiers that makes it perfectly clear to the CA which certificate or certificates I want to extract. So let me go get, for example, the serial number. The orthodox approach, the one that you'll see in Microsoft's written material about this subject, suggests using the serial number. I can see the serial number appearing over here in this rightmost column. I can actually copy it onto the clipboard, which I always find handy, from the inside of the description of the certificate. So let me go to my Details tab. There's the serial number field. I'm going to click and drag to highlight that set of data. I'm going to Control-C to copy. For some reason, Microsoft did not enable a right-click option there. So I now have the serial number of the certificate that I want to get the private key for on the clipboard. Let me jump over to my command line environment. And I'm going to issue the command certutil-get-key, and I'm going to supply inside of quotes what should be my certificate serial number. Why did that not work the way I expected? Let's try that again. Control-C to copy. Back to the window. Right-click. There we are. So there's the serial number for that cert. Let me close off my quotes and hit Enter it. And we can see that it does retrieve information about that certificate. I want to take that data and save it into a blob file. All I need to do to be able to make that happen is identify the name of my blob. Microsoft's examples tend to use things like output blob.p7b. P7b extensions are associated with the PKCS number 7 file that contains the certificate and the private key that goes with it. That looks good. If I do a directory here in Susan's account, she does have the output blob file waiting for her. Next step is to transform that file into something that the user can re-import. And that's another certutil function, certutil-recover key. Takes an input of which file has the blob in it. In this case, it's output blob.p7b. and then the name of the file that I want to create as a result of this. And I'm going to call it Don Clouser EFS cert dot PFX is the common extension that you'll see with a PKCS number 12 personal information exchange file. When I run that command, it prompts me with a somewhat surprising prompt. It says, enter a new password. Private keys never travel without being protected by a passcode. So I need to supply a password here so that if this file falls into enemy hands, I've got at least some degree of protection from the bad guy using that private key. So in this case, I'm going to supply a password, and it'll ask me to confirm it. Looks good. Command completed successfully. If I do a dir, I've got Don Clouser's EFS cert waiting to be handed off to the client. I suppose I could put that in an email, I could put it on a USB stick and walk it over. In this case, I'm just going to go copy it right onto the hard drive of that computer. So to do that, I'm going to go map a drive to the Windows 8 client. I'm going to use the good old classic netuse command. Remember that one still works. Netuse L / Windows 8 client /C $. And it says, who are you? I'm going to be the administrator. It says, what's the administrator's password? There it is. Let me take another run at that. Maybe I mistyped my password. And let me go so far as to actually insist that I'm the Global Mantic administrator, whose password looks like that. There we go. So I'm going to make a new directory inside of the L drive, L : certs. Looks good. And I'm going to copy Don's PFX file into L : certs. So far, so good. Let's jump back over to the client machine and let's get Don back to work. So back here on the client, Dawn's still trying to get into her file and finds that she can't, when she gets a call from Susan. Susan says, hey, I've got a solution to your certificate problem. Oh, great, says Dawn. What do I do? You need to launch the certificate manager tool. Oh, okay, I can do that. So she goes to the start screen, certmgr.msc. In which case, she can go back to her recently emptied personal certificate folder, and right-clicking can go request to import a certificate from somewhere. When it comes in, the certificate will be associated with the current user, of course. What's the name of the file that we're extracting? Well, we're going to go browse down into My Computer, C drive, search directory. I'm looking for a file that is a Personal Information Exchange PFX file, and there it is. I'll open that file. I'll click Next. And it says, hey, that's got a private key in it. Who are you that makes you think you can get at that private key? You see the importance of the password. If that file had fallen into enemy hands and was not password protected, the bad guy would be able to grab a hold of that private key and be able to impersonate Dawn. Let me go ahead and supply that password. I'm going to mark this key as re-exportable later on if Dawn wants to make her own private copy of this. Having learned a lesson about solar flares disrupting your hard drives or lightning strikes or whatever it might be, she may want to actually make her own copy of that certificate. I click Next. Where do I want the certificate? In the personal store. That makes sense. Confirming my settings. That looks great. I'm going to click Finish. The import succeeded. Dawn again has a certificates folder that contains a certificate named for her from Dallas Server 2 CA that is an EFS certificate. If I double click it and go to its Details tab and go visit its thumbprint, there's our good friend 9BE6. And that means that because that certificate is there, Dawn should now be able to double click her employee data file with the CEO's social security number in it, and it opens. So a lot of pieces had to come together to make that work. We needed to tell the CA that it was going to engage in the certificate key archival process. We needed to tell it who the user was who was going to be able to do that certificate extraction. That needed to be accomplished by configuring and publishing the key recovery agent certificate on the CA. and enrolling a user for it. And we needed to configure the template that the user was requesting to take advantage of that ability to archive a key at the CA. Having done all that, we logged in a user. The user requested a key, got the key, behind the scenes archived the key, and then used the key. Having done that, we inadvertently destroyed the key through some natural disaster, and then we saw that the key recovery agent was successfully empowered to extract that certificate, extract the private key from it, and repackage that key in a way that we could re-import it into the user's computer and get back to work. I hope that all of your key recoveries go as smoothly as this one did. And I look forward to sharing other advanced Windows Server 2012 techniques with you in other lessons.